Right, so this next example that we're going to go through, we're going to kind of walk through an entire sampling distribution problem. So a sampling distribution is a special name for the probability distribution of a statistic that is used to make inferences about a population. Sampling distributions give us all of the outcomes for the statistic, the probability of each outcome occurring, how often we expect to see particular values of our statistic, and it also will give us characteristics like bias and precision. So in this example, we're going to kind of talk through how our sampling distribution gives us all of this information above. So we have a small population of 6 people. So this is not a sample. Again, we are looking at a population. So in this particular problem, only these 6 people matter. They're representing an entire group of people that we are looking at. Out of these 6 people, 2 are cat people and 4 are dog people. Right, so our population I have listed out D1, D2, D3, and D4. Those are the dog people, and then C1 and C2, those are the 2 cat people. I found our population parameter, which is our P. So again, thinking back to our notation that we mentioned in the previous section, population parameter means a numerical statement about our entire population. So if we look at our entire population, what percentage are cat people? Well, we have 2 out of 6. Right, that's going to reduce to 1/3, which is going to give us 0.333. All right, now instead of looking at our entire population, we're going to take samples of size 4. So what I have put in this table are all of the different possibilities, all the different combinations that are actually possible of coming up with samples of size 4. So one possibility is that we get a sample that has all 4 dog people, right? And if that's the case, well, our percentage of cat people is 0. Notice that we're using the p hat here because now we're looking at a sample of 4. Right? So our population was 6, we have a sample of 4. Right? In our second sample, we have D1, D2, D3, so 3 dog people and 1 cat person. Right? 1 out of 4 gives us 0.25. If we finish off this column, notice that we have different combinations of dog people, but each time there's exactly 1 cat person. So all of the rest of these are going to be 0.25. Right, so again, 1 out of 4 in each of these samples is a cat person. We look at our 9th sample over here. We still have 1 cat person, 3 dog people, so that's also 0.25. Then if we look at samples 10 through 15, notice that we have 2 cat people and 2 dog people. So 2 out of 4, or 1/2, gives us 0.50 for the rest of these. All right, now if we want to find our mean for all of these values in our table, this little guy here, this should not be an X. We're going to turn that into a P hat. We are going to add up all of these different values that I just put in our table in red. So into our calculator, we're going to type 0 plus 0.25 plus 0.25, 0.25 all the way through, and then a bunch of 0.5s. And if we add this all up, we end up with a nice total of 5.00. And then we're going to divide that by our number of samples. Well, our number of samples was 15. And if we take 5 and divide it by 15, reduces to 1/3, we get 0.333. So we listed or had all of our samples that were listed that were given to us. We found our p hat for each of these. So for each individual sample, how many of those people were cat people. Then we took all of those percentages and added them up and then divided it by our total number of samples. We're going to take this information and we're going to use this to fill in our little table at the top of the next page. and then we're going to do a little graph. Both of these thinking back to stuff that we saw in chapter 6 where we're thinking about discrete probability distributions. Right, so I'm just going to move this table up a little bit. So looking at this table, we have exactly one row that has a 0 in here. Right, so our sampling distribution, our possible outcomes for p hat, we had 1 0 out of 15. 1 divided by 15 gives us 0.067. Right, now we're going to look at this table and we count up the number of 0.25s. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 of those. So our probability 8 out of 15. We change this to a percent, 0.533. Then our last one, how many 0.50s? Well, we have 1, 2, 3, 4, 5, 6. So 6 out of 15. This one actually divides evenly and we get 0.4. So then we can graph each of these as a discrete probability distribution. So 0, we have 0.067, so just a short little piece here. 0.25, we have 0.533. Right, and 0.50, we have 0.4. So in your homework, for the most part, you're not going to have to worry about going through and creating the sampling distribution as we did here, and or making the table or graph, but this was just kind of a nice way to tie everything that we've done together, and then kind of compare our population parameter to our different samples and our different possibilities.